So here's a harder yet problem. Here's the picture. We have an inclined plane, 37 degrees again. Put that in here. And it's a frictionless incline. And what that means is that the 5-pound object, which is long extended sort of object here for this particular setup, slides frictionlessly on this surface. Now the 5-pound object is tied to a string which passes over an ideal pulley, which then comes down and attaches to a 2-pound weight, which is on top of the 5-pound weight. And that surface is not, the surface between the 5-pound and 2-pound weights is not frictionless, but we don't know the coefficient of friction. That's one of the unknowns in this problem. The 2-pound weight is moving in this direction. The 5-pound weight is moving in this direction. So this guy's going down the incline, this guy's going up the incline, and they're moving with constant speed, so it's a Newton's first law problem. So we need to choose a body, and I'll start with the 2-pound object. So we have our 2-pound object sitting like this. And what are all the forces on it? There's its own weight, which is 2. There is a tension in the string, which is T. There is a normal force, which I will call N sub 2, because that's the normal force on 2 due to the presence of 5. The 5-pound object is exerting a force, a contact force like this. Also, there is a frictional force, F2. F2 is the frictional force exerted by the surface of the 5-pound object on the surface of the 2-pound object. And that's everything. So now let's choose a coordinate system, and I'll choose one where the y-axis is like this, the x-axis it's not so good, but you know what I mean. The positive x-axis is this way, the positive y-axis is this way, and so now I have to resolve my forces, and so now I will do that in green again. So the two components of the 2-pound force are like this, and this is 37 here. So the two components are, let's do those in green. This is 2 times the cosine of 37, which would be 1.6 pounds. This is 2 times the sine of 37, which would be 1.2 pounds. And so we've got everything resolved, and so now we can apply Newton's first law. Sum of the forces in the y direction is equal to 0, which is equal to N2 minus 1.6. And so that tells me that N2 is 1.6 pounds. And it tells me that the frictional force, F2, is equal to, in magnitude, 1.6 times the unknown mu. Now the sum of the forces in the x direction also has to be equal to 0. And so this is equal to minus 1.2. That's the component along the incline of the weight. And then we have plus T, that's the tension. And then we have minus 1.6 mu, that's the frictional force. So let's take stock of what we have now. We have two equations, but we have three unknowns, N2, T, and mu. We have found out what N2 is, but we don't know what T or mu are. And so we're going to hang on to this equation, and we're going to see if we can find another equation which involves these three unknowns, or maybe we'll even get more unknowns, who knows. So let's extend the page here a little bit, and let's choose the only other obvious body to choose, which would be the 5-pound object. Oop. So, what are the forces on this guy? Well, there's his own weight, which is 5 down. Okay. There is a normal force on him due to the surface that he's sliding on, which I will call N sub 5. Okay. There's no frictional force, but it is in contact with something else. The 2-pound object exerts forces on it. The 2-pound object presses down with some force, and it also is trying to slow this guy down, so there'll be some frictional force. Okay, so this is, I would call the frictional force on 5. And this one, let's just call that N2 prime. Okay, so basically you see what's happened is we have chosen another body, and we have gotten 1, 2, 3 more forces. Okay, so let's we're getting into a little bit of trouble, it would seem here, because we had one equation and 2 unknowns. If we solve this problem, it looks to me like we're going to have 3 equations, because we'll get the x and y equations for this guy, but we have in fact introduced 3 more unknowns. But aha, let's have a look at what's going on here. Now this is why I wanted you to understand Newton's third law before I started doing more complicated examples, because we know what F5 is. Okay, F5 has got to be equal to minus F2, and N2 prime has got to be equal to minus N2. Why? Because of Newton's third law. F5 is the frictional force that the 2 exerts on the 5. F2 is the frictional force that the 5 exerts on the 2. N2 is the force that the 5 exerts on the 2, and N2 prime is the force that the 2 exerts on the 5. Okay, and so now I'm ready to write the sum of the forces in the y direction. Better choose a coordinate system first, I guess. Let's see here. Let's choose a y-axis like this and an x-axis like this, as you would expect. And so now we need to resolve our forces. And once again, the only one that we need to resolve is this 5. So let's find the components of 5. Okay, so here is one component. Here's the other component. If this is 5, then this is 4 and this is 3 in magnitude. And so the sum of the forces in the y direction is -4. That's this guy. Okay. And then we have N2 prime is pointing in the negative direction, and it's got to be the opposite of N2, and so it's -1.6. Okay. And we also have N5, like this. Okay. And so this allows us to write down that N5 is equal to 5.6 pounds. Sum of the forces in the x direction is equal to -3 plus t. Hey, I just noticed something. I hope you had noticed this too. But this is really messy. I apologize. I'm going to get better at this, I guess. There's going to be a force T. Let me draw it up here. I forgot to put the tension in this string T in here. Okay, back here. Okay, so it's -3 plus T plus F5, but F5 is the same in magnitude as F2, so that's plus 1.6 times the unknown mu. And that's everything. All that has to add up to 0. Okay. And now I have two equations in boxes here. I have two equations and two unknowns. All right. So all we have to do is know algebra and solve these two equations. I'm assuming that you all know the algebra. Here's the way I would solve this problem. I would look at these two and I say, well, look at this equation has a 1.6 mu in it, and this equation has a -1.6 mu. So if I add these two equations, this one and this one, then I get mu goes away. So what I get is I get -1.2 plus t -3 plus 2t, sorry, equals 0. So t is equal to 2.1, I think. Yep, 2.1 pounds. And now that I know t, I can take it and put it into either of those two equations and find, for example, that mu is equal to 3 minus 2.1 divided by 1.6, which is equal to 0.56. And that's the end of this problem. So, although your VideoMeister has a little bit messy pictures here, didn't allow myself quite enough room, I hope you can reconstruct this problem for yourself. It's instructive because you have to use Newton's third law when you're thinking about the force that this guy exerts on this guy and vice versa. Okay, that's it.